So, welcome to the new lecture of this course again, properties of materials. So, let us just briefly recap what we were doing in the last lecture. So, in the last lecture we looked at the definitions of normal stress, which could be sigma xx, sigma yy, sigma zz, or we can have shear stress, which is sigma xy, sigma xz, sigma yz, and this could be also yx, zx and zy, and these are generally referred as tau ij instead of sigma. And by definition, normal stress is basically the stress which is arising from a force that acts perpendicular to an area, and shear stress is because of force that acts along, let us say in this case j direction, and the acting on and it acts on a plane which is normal to I direction. Okay. So, this is what is the definition of tau ij, and we also did we did a brief example of stress evaluation along different set of axes, and then we also looked at the sign convention. By the way, just I forgot to tell you that you can read all this from a book. Title is, so book reference, it is a very good book, Mechanical Behavior of Materials by W.F. Hosford of Cambridge University Press. So, this is a very good book. If you can get this, all of this will be available in this book, particular book. All right. So, at the end we were trying to do the transformation of axis in a general sense. And so, basically we said that we have we start with this coordinate system, which is, let us say, x, y and z, and we want to transform to x prime, y prime and z prime, which is a new system which is at certain angle to the original ones. So, essentially let us say we define them as one set of the first set of orthogonal axis as I, j, k, and then we have second set of orthogonal axis that can be defined as m, n and p. So, by using the stresses in a new system in general can be defined as, so stresses can now be expressed as sigma ij is equal to n is equal to 1 to 3 summation over n is equal to 1 to 3, m is equal to 1 to 3, this will be Lim, Ljn and sigma Mn. So, the n is here summed over 1 to 3, the m is summed over 1 to 3, and of course Ij vary from 1 to 3, but at one time you can take only two of them. So, I, j, k can vary from 1 to 3 and M and P can also vary from 1 to 2 to 3. Okay. So, here what is now, this is basically because of matrix transform, because the tensors have matrix properties. So, essentially we are using the characteristics of matrix, and LMN here is defined as cosine of angle between, let us say, I and M axis. Similarly, LJN here would be the cosine of angle between M and N axis. Okay. So, in a general form you can get rid of the summation symbol, which means it is implied or it is assumed that it is there. So, in a general manner you can write this as sigma ij is equal to L I m into L of j n into sigma m n. So, which means here the summation over m and n is assumed. Okay, it is by default there. So, let us say you want to transform the stress from let us say x, y, z to x prime, y prime, z prime, okay, the new system. So, let us say, let us first begin with x prime, x prime. Okay. So, sigma x prime can be written as L of x prime x into again L of x prime x into sigma x x. Okay. And then this becomes, now the second term will become L of x prime y, L of x prime x into sigma y x. So, we can see that we are varying this was x prime here x. So, we are varying the x here to x to y, and this x corresponds to this x. So, this was x earlier, it becomes y, sorry y x, not y z, hang on, y x, okay, because it was sigma m n. Okay. So, we are varying at the first, in the first row we are varying m, and then the second term becomes third term becomes L x prime z, L x prime x, sigma z x. So, we can see that we have vary only one term, that is the m term. So, m term has changed from x to y to z. Similarly, stress also, this was sigma m n. So, it has become sigma x x, sigma y x and sigma z x. Now, let us look at the other term. So, now we will vary n. So, in the first case n was equal to x, x prime, now the n will become equal to y. So, the first term remains x prime x. So, this x prime will be, this x will now become y, okay, and here sigma will become sigma x y. This will become sigma x prime y, this will become sigma L x prime y. So, now you can see it is varying vertically, and this will become sigma y y. Third term will be L x prime z, L x prime y into sigma z y. Coming third row will be x prime x, L x prime z. So, you can see that x has gone from, and this similarly here it will become sigma x z. Again L x prime y, L x prime z, sigma y z, L x prime z, L x prime z into sigma z z. So, you can see that in this case this digit has changed. In the first case it was the first digit. So, this changed from here to here, from here to here. Similarly, in this case this particular digit, and this particular digit. So, in the first row we vary m, and the second row wise we vary m, and the column wise we vary n. Okay. So, this is what the general expression for the stress will be. You can also write, let us say, sigma x prime y prime, alright. So, what will sigma x prime y prime will be? This will be sigma L x prime x, L y prime x, sigma x x plus L x prime y, okay, L y prime x, sigma y x plus L x prime z, L y prime x, sigma y, sorry, z zx, plus we can write L x prime x, L y prime y, sigma x y plus L x prime y, L y prime y, sigma y y plus L x prime z, L y prime y, sorry, y, sigma z y plus L x prime x, L y prime z, sigma x z plus L x prime y, L y prime z, sigma y z plus L x prime z, L y prime z into sigma z z. Now, of course, so these are the two expressions. Similarly, you can write other expressions as well. Now, by symmetry we know that sigma ij is equal to sigma ji, and this I is not equal to j. Okay. So, if we apply this and we write sigma I as sigma I, so we can write this as sigma x prime, which is nothing but sigma x prime is equal to L of x prime x square into sigma x plus L of x prime y square into sigma y into L of x prime z square sigma z plus 2 of L x prime y. So, basically we can write this as tau ij or tau ji. So, we will introduce this tau x yz plus 2 L x prime z, L of x prime x z L, sorry, just one second, L of x prime z, just one second, x prime x into tau of zx and plus 2 of L of x prime x into L of x prime y to tau of x y. And this you can do yourself as a home exercise. It's a little bit tedious but not complicated, so it just needs to be done. And similarly you can write the expression for this. So L of x prime x, L of y prime x sigma xx plus L of x prime y, L of y prime y sigma yy plus L of x prime z, y prime z sigma 3 3. So first three principal components, and then we write the shear component. So this will be first one L of x prime y plus into L of y prime z plus L of x prime z, L of y prime y into tau yz, L of x prime y plus L of x prime z y prime y, yeah. And then second one will be L of x prime z y prime z plus L of x prime x y prime z into tau zx. And the third term will be L of x prime x, L of y prime y plus L of x prime y, L of y prime x into tau x y. So these are the stress components that we write by doing the transformation. So if you go back to previous slide, essentially the transform is this is the formula, all right. So essentially you can calculate any stress, it could be ij, so it could be ij, it could be, so essentially if you take, you can calculate sigma 1 1, you can calculate sigma 2 2, you can calculate sigma 2 3 and so on and so forth, sigma 3 3 and 1 2, sigma 2 3 and sigma 3 1. All of these can be calculated in the new system. So let us say in the new system it becomes 1 prime 1 prime, in the original system it was, so the transforms could be sigma 1 prime 1 prime, it could be 2 prime 2 prime, 3 prime 3 prime, 1 prime 2 prime, 2 prime 3 prime and 3 prime 1 prime. So it could be any of them, and you can calculate just by using this formula, where your original one system is ijk, second system is MNP, and you can transform between the two the way you like using this formula, which is a bit tedious to write, but it's fairly straightforward. You just have to vary in one row, you vary, let us say m, and the column, so in rows you vary m, and the columns you vary n, and the ij remains same as what you write on the left. Okay. So if you, so just as a home exercise, I mean you can write the expressions for, let us say sigma 1 prime 1 prime. What will this be in terms of original system? Similarly you can try writing expression for sigma 2 prime 3 prime. What will this be in terms of? So you can see that, for example, when you write this, so let's just do a simple. So we say that the formula is sigma ij is equal to n is equal to 1 to 3, sigma m is equal to 1 to 3, L I m, L j n and sigma m n. Let us say I want to calculate what is sigma 1 prime 2 prime. So if I write this as an expression, so let us say the first one, it remains n to 3. So I fix certain things here, sigma 1 prime m, sorry, not sigma, L 1 prime m, the second one becomes L 2 prime n, then this becomes sigma m n. So I am only now left to vary m and n. First we vary along the row, okay. So the first term will become L 1 prime 1, L 2 prime 1, sigma 1 1. Now we vary L of 1 prime 2, L of 2 prime 1 remain this one, this will become 2 1, and this will go 1 prime 3 L 2 prime 1 sigma 3 1, alright, this fine. Now you come to, this will remain sigma 1 prime 1, this will be sigma 2 prime 2, this will be sigma 1 2. Now you again go this way, so this will, now you are changing L 1 prime 2, L 2 prime 2, and this will become sigma 2 2, and this will now, you are, this is sigma 1 prime 3, L 2 prime 2, and this is sigma sigma 3 2. This will remain 1 prime 1, this will become 2 prime 3, this will become sigma 1 3. This will remain 1 prime 2, this will remain 2.3, this will become 2 3, and this will remain L 1 prime 3, this will become 2 prime 3, and this will become sigma 3 3. So this is what will be the new stress tensor. So of course you can replace, since these are all, these can be replaced by taus, so you can replace so this is how you write the stress tensor for various of these stresses. So if you now apply this to problem done earlier, okay. So now if we apply this to the problem that we did earlier, we draw the same box, so we made a plane which was like this, okay. So this was, let us say, Ay prime, this was Fy prime, this was Fy, and this was Ay, okay. This was x, this was x prime, and of course y and y prime are listed there, and this angle was basically, you can say, theta. So now if I go by the same logic that I have applied here, this sigma y prime will become Ly prime y square into sigma yy. So basically sigma yy prime, right. And if you do the maths, basically Ly prime y is the cosine of angle between y and y prime. So this is basically sigma y into cos square theta. Similarly, if you want to calculate what is tau of x prime y prime, this becomes tau of L of x prime y, L of y prime y into sigma yy, other terms are 0, okay. So if you just calculate this, this will become sigma y, L of x prime y and L of y prime y is, so this is sin theta, this is cos theta. So this is same result that we get, what we got from earlier exercise that we did. So what essentially we have done in this so far is we have written a general equation through which you can transform the, you can estimate the stresses along different axis coordinate system by using this transform. This is nothing but from matrix characteristics, and we tried doing this for, let us say, two principal and shear stresses, that is sigma x prime and sigma x prime y prime, and then we did a general case for, and you can then apply the symmetry properties which make sigma ij being equal to sigma ji, and then simplify these above equations, and then we did finally one exercise for hypothetical case of sigma 1 prime 2 prime, and again you can simplify this further by making these equal. So these will become equal, these will become equal, and these will become equal. So as a result you can simplify this equation, and so essentially that is what we have done in this lecture. Now finally what we did was we applied the same transform to the problem that we did earlier manually, and if you apply the transform you come up with the same result. So it basically validates that what we did earlier was correct. Okay. So now let us move further and define some more things. So we define what we call as principal stresses. Okay. So in principal stresses, generally if you define axes as 1, 2 and 3, then these are called as principal stress axes, and the principal stresses will be sigma 1 correspondingly sigma 2, sigma 3. If 1, 2, 3 are principal stress axes, the stresses along these are called as principal stresses. So based on the characteristics of these stresses, one can define an equation that sigma p cube minus I1 sigma p square minus I2 sigma p minus I3 is equal to 0. So this is a relation which basically defines the principal stresses, and this P subscript is essentially about the pressure. Okay. And here I's are I1, I2 and I3 are called as stress invariants. These invariants remain independent of axis transformation, and one can write this I as I1 as sigma xx sigma yy plus sigma zz. I2 can be written as sigma yz square plus sigma zx square plus sigma xy square. You can write them tau xy, tau S1, and this becomes, next one is sigma yy minus of sigma yy sigma zz, then we have sigma zz sigma xx, and then we have minus of sigma xx sigma yy. So you can write them as tau yz square plus tau zx square plus tau xy square minus sigma y sigma z minus sigma z minus sigma x minus sigma y. So this becomes sigma x plus sigma y plus sigma z. Similarly, I can write I3, which is sigma x sigma y sigma z plus 2 of tau yz tau zx into tau xy minus of sigma x tau yz square minus of sigma y into tau zx square minus of sigma z into tau xy square. So we will stop here. What we have done is basically we have looked at transformation of stresses from one set of axes to another set of axes using a simple formalism. Do that exercise at home, and it is a bit tedious, but it is simple, and once you get the habit of doing it you will be alright with how to do it. So we will stop here. We'll take up this principal stress formalism further and do a problem to understand what it is. Okay. Thank you very much.